Okay. Divisible by small numbers. So divisible by 2. Checking if a number is divisible by 2 is easy. Even if a number is even, then it's divisible by 2, and vice versa. To check if a number is divisible by 2 or not, just check if the last digit is even or not. Given any two consecutive integers, one of them will be even and divisible by 2. Divisible by 3. An integer is divisible by 3 if the sum of its digits is divisible by 3. 327 equals 3 times 109, so 327 is clearly divisible by 3, but we can add the we can sum the digits up, so 3 plus 2 plus 7, which is 12, and check if that's divisible by 3, which it is, so 327 is divisible by 3. Is 246,150 divisible by 3? We can sum the digits up. 2 plus 4 plus 6 plus 1 plus 5 equals 18. And 18 is divisible by 3. So 246,150 is divisible by 3. And 246,150 is equal to 3 times 82,050. Divisible by 4. All multiples and sums of multiples of 100 are divisible by 4. 10 squared, 10 cubed, etc. are divisible by 4. We can check if a number is divisible by 4 by looking at the last two digits. If the last two digits are divisible by 4, then the entire number is divisible by 4. So which of the following numbers are divisible by 4? 1,437,640,856, 433,452,254, and 134,567,896. The last two digits of 1,437,640,856 and 134,567,896 are divisible by 4. So they are both divisible by 4. The last two digits of 433,452,254 are not divisible by 4. So 433,452,254 is not divisible by 4. Divisible by 5. Checking if a number is divisible by 5 is extremely simple. To check if a number is divisible by 5 or not, simply check if the number ends in a 5 or a 0. If it does, then the number is divisible by 5. Is 1,234,567,890 divisible by 5? 1,234,567,890 is divisible by 5 because 1,234,567,890 ends with a 0. Divisible by 6. To check if a number is divisible by 6, the number must pass the divisibility criteria of both 2 and 3. If the number is even, the number must be even, and the sum of its digits must be divisible by 3. So is 6,714 divisible by 6? Well, we sum the digits up, and the sum of the digits is 18. 18 is divisible by 3. 6,714 is even. So that means 6,714 is divisible by 6. Divisible by 7. To check if a number is divisible by 7, extract the last digit of the number, double it, and subtract it with the remaining digits of the number. If the result is divisible by 7, then the entire number is divisible by 7. You can do this process several times if the number is too large. Is 203 divisible by 7? Well, we take the last digit, which is 3, we double it, so we get 6, and we multiply 6 with the remaining digits, which is 20, and 20 minus 6 is 14, so 14 is divisible by 7, so that means 203 is divisible by 7. Divisible by 8. 1000 is divisible by 8, so it's every multiple of 1000. To check if a number is divisible by 8, check if the last 3 digits are divisible by 8. Sorry, there's a typo. Which of the following numbers are divisible by 8? 7,892,305, 47,243,535, or 9,871,200. 9,871,200 is divisible by 8 because its last 3 digits, 200, is divisible by 8. 7,892,305 and 47,243,535 are not divisible by 8 because 305 and 535 are not divisible by 8. 305 and 535 are the last 2 digits of those two numbers. Last 3 digits of those two numbers. Divisible by 9. Every power of 10 is 1 more than a multiple of 9. 10 equals 9 plus 1, 100 equals 99 plus 1, 1000 equals 999 plus 1, and it goes on. Checking if a number is divisible by 9 is similar to checking for 3. The remainder of dividing n by 9 is r. If and only the remainder of dividing the sum of the digits is r. In other words, the number is divisible by 9 if the sum of the digits is divisible by 9. Is 112,779 divisible by 9? Well, we add up the digits. 1 plus 1 plus 2 plus 7 plus 7 plus 9 equals 27. And 27 is divisible by 9. So 112,779 is divisible by 9. Divisible by 10. Checking if a number is divisible by 10 or not is just as simple as checking for 5 and 2. If the last digit of the number is 0, then the number is divisible by 10. Is 999,999,990 divisible by 10? 999,999,990 is divisible by 10 because its last digit is 0. 999,999,990 is equal to 99,999,999 times 10. That is the end of my presentation.